Hello everybody, welcome to Sane Game Studios. I'm Sane, I'm an amateur game developer. Today on Gamemaker for Beginners, we're going to be taking a look at advanced collisions. So what are advanced collisions? If you watched my previous video, basic collisions, you have a good understanding of what a basic collision is. An advanced collision is just a little bit more complicated of a collision check. These include functions like collision circle, collision ellipse, collision line, collision point, collision rectangle. One thing that's really interesting about these collisions is that the vast majority of them, the only exclusion being collision point, is that the function itself is going to ask for arguments that is going to create the area for the collision. So we won't actually be using the collision mask of the instance that is calling the collision. Instead, we are going to be using the function to create an area in which we check for the collision, and then we'll be checking for collisions inside of them. But jumping into this, if you did watch my previous video on basic collisions, you're going to recognize everything that I have set up here for this project. I am using the exact same project. I have the same player, the same wall. The only difference is that I've removed any collision checks that would have carried over from the previous video. So we legitimately just have some top-down movement code. If I go back to my room, you're going to recognize this room. I'm going to change this up just a little bit. I'm going to get rid of these walls, and I'm just going to place a couple more. Yeah, like so. And these are just going to give us instances in which we can look for. Because the collisions that we're going to be covering today, under no circumstance should they be used for movement. They are for essentially detecting proximity. There's a lot of things you want to be detecting proximity for. A good example is like our first collision we're going to be doing today is going to be collision circle. I use collision circle in combination with collision line to do my enemy sightseeing. Sometimes I'll even use point and triangle combined with collision line to do my enemy sightseeing, where I can create a line of sight for the enemy to figure out whether or not they have actively detected the player. But with that, we can actually essentially just get into this. The first thing I'm going to do is I'm going to go to my create event, and I'm going to create a new variable, and I'm going to call it found, and it is going to equal false. And then, like I said earlier, the first one we're going to be doing is going to be collision circle. So collision circle takes a handful of arguments. The first thing it's going to do is it's going to want an x and y coordinate, and that is going to be the center of your circle. I'm going to be using my player's position for this. The next argument it's going to ask for is the radius of the circle, and I'm actually just going to make this 300. And then when I mean radius, I don't know, if you've done like high school math, you probably know what a radius is. But the way this is going to work is I'm going to have, a point like right there. And that's going to be like my player, right? And then I'm going to be drawing a circle around that player, and I want this circle to be my collision circle. So what's happening is I need to get this distance right here, and then that is going to be what's used to create the circle. Like I said, if you've done high school math, you should know all about this. The area of a circle equals like pi r squared or something like that. But yeah, that's how Gamemaker is going to create the circle. It's going to take a center point and a distance to travel, and it's going to draw the circle from there. I'm going to be using 300 because the radius is always going to be measured in pixels. Pretty much everything in Gamemaker is going to be measured in pixels. The object that I want to be checking for is a wall. The next is precise, and this is a boolean. You toggle it true or false, and this is going to say whether or not you want your collisions to be precise. And what is precise? So for this, I'm just going to create a new sprite real quick. edit image, create a circle. So see, now we have this circle here. And if I go to my collision mask, as you can see, the collision mask is a square. So like if I'm colliding with this thing and I'm up here in the corner where I'm not actually touching the circle, but I'm within the collision mask, then that is going to be considered a collision. But then if I change my type of collision mask to precise, the collision mask is going to become the circle itself. So that's going to make it so that when I'm right here, I am no longer actually going to be colliding with this circle. I'm only going to be colliding with the circle once I actually collide with the circle itself. And that's essentially what precise does. So precise is going to be looking at the exact shape of the sprite and then figuring out whether or not it is colliding not within a rectangular collision mask, but within, in this case, a circle. But this only works if in your sprite you have your collision mask set to precise. For the vast majority of collisions, you will not need precise. I'm going to set this to false. And then the last argument it's going to be asking for is not me. And this is one you actually only really need to worry about if it is relevant. Right? So let's say I had an instance of a wall calling for a collision circle with a wall, but I do not want the instance that I've actually called the function with to be included in the function. I want it to be excluded. I would set not me to true. I'm not sure if that's a little bit confusing or not, but essentially it's going to ensure that whatever instance is actually using this function will under no circumstance be considered in collision with this function. In this case, because I only have one instance, and I'm only ever going to have one instance of OPlayer, it doesn't actually matter. I can set this to false. But setting it to true will also make no difference. But like I said, I'm going to set this to false. And collision circle is also a really cool function in the sense that it does return an ID. It does give you the ID of whatever instance you are colliding with. What it also does, however, is it can be used as a Boolean, which is very cool. Again, in my last video, I called these type of collisions hybrids because they can be used either to get the instance ID or as a Boolean, true or false. So to show you what I mean, I'm going to go if collision circle found equals true, else found equals false. And then I'm going to open up my draw event. Since I've opened up the draw event, I need to draw self. And then I'm going to draw text. Well, actually, if found, I'm going to draw text. I'm going to draw to x, y minus 50, and the string I'm going to type is going to be found you. But then I'm also going to draw a circle. That way we can actually see the collision mask. I'm going to go x, y, radius 300, outline, true. So I'm going to draw a circle that is the exact same position and radius as my collision circle, so we can always see where my collision circle is. So if I run this now, As you can see, I have a circle. Not gonna lie, it's actually a pretty rough looking circle. Then if one of my instances of a wall enters my circle, it's gonna say, found you. Then if none of them are in the circle, it's not gonna say that. I'm going to change this up a little bit. Instead of found equaling false, I'm going to have it equal no one. And now I'm going to say found equals collision circle. And then as you're going to see, it's going to actually grab the instance ID and it's going to display that in found. There you see ref instance 100002. But then -4, which stands for no one. Right, as you can see, I can use collision circle to also get the ID of things. So the next function we're actually going to be looking at is going to be related to collision circle, and it is going to be collision circle list. Now, the first thing I need to do to be able to use this is I need to create a list. So I'm going to go var list, and it is going to equal ds list create. Since I've created a list, the first thing I'm going to do is I'm going to go ds list destroy list. So for collision circle list, I'm going to do the exact same circle. I'm going to go x, y, 300. Well, oh, wall, precise, false, not me, false. List is going to be list. And ordered is going to be false. I want to put them in the list in no particular order. Now I'm going to store the amount of instances in this list inside of this local variable called walls. Next, I'm going to say that if walls is greater than 0, which means that I have found a wall. Sorry, I'm actually assuming you've watched my last video here. If you haven't, that's fine. So what collision circle list is going to do is it's actually going to find the every instance of a wall inside of that inside of this circle, and it is going to store all of their instance IDs inside of a list that I have created here. But then this function is also going to return the number of walls that I have found. So if I'm colliding with all 3 walls, it is going to return the number 3 and store it in walls. If I am not colliding with any walls, it's going to return the number 0 and store it in walls. And it's just going to store the quantity of walls that I have found inside of this circle inside of this variable. So by asking if walls is greater than 0, I'm asking if it has found a wall. So if it has found a wall, I want to do some things. The first thing I want to do is I want to loop through the every single instance on that list, and I just want to count them, essentially. So I'm going to say for, so I can create a loop, var I equals 0, I is less than walls, I plus plus. And that is just going to create a loop that is going to increase I by 1 until it has the exact same value of walls. And every single time it does that, it's going to execute everything in between these two brackets. First thing I want to do is I want to grab that instance that I'm looking at inside the list. So I'm going to go list. I'm going to store the ID of whatever instance I'm looking at in the list inside of this variable. And then I'm actually not going to do anything with that yet. All I'm going to do is say found plus plus. And then actually right here, I'm going to hard code found to equal 0. And right here, I'm also going to hard code found to equal 0. And what that's going to do is where I'm drawing found above my head, where we were seeing the instance ID before, instead we're going to see a number that is going to tell us how many walls that we have found. Alright, so here you see I found 1 wall, 0 walls, 1 wall, 2 walls, 3 walls. But let's actually do something with them. So I'm going to go current dot image blend equals C red. Then I'm actually going to go to my room and I'm going to move this wall down a bit so I don't automatically collide with it. And then you're going to see they're going to change color when I collide with them. So it changed to like a black. I was honestly hoping that since they're pretty much blue, that they would turn green. But as you can see, I can affect each instance of a wall on a per instance basis by looping through them on my list. And that is a good example of how the list functions work, and all the list functions are going to work the exact same way. The only difference is we're going to be changing how we are colliding. It is not ever going to change how the list aspect of the collision works. So every single one of the functions I'm going to be covering today has a list variant. This is the only one in which I'm actually going to be using the list and actually calling the list variant of that function, because like I said, they all work the same. If you are really confused about a for loop, that is fine. I am making a video on loops that is going to be coming rather soon. But with that, we can actually move on to our next function, which is going to be collision rectangle. So collision rectangle is essentially exactly what it sounds like. It works the exact same way as a collision circle. The only difference is you're going to be using a rectangle, but it can be used to either get the instance ID of the instance that you're colliding with, or it can be used as a true or false. That is completely up to you. So I'm actually going to change this again. I'm going to change it back to found you. I'm going to say if found, and I'm going to change found back to a Boolean. So I'm going to go if collision rectangle. Alright, so now let's actually do collision rectangle. So this is actually going to require 4 coordinate positions: x1, y1, x2, y2, and it is going to take 2 points, and it is going to draw a rectangle using the first point as the top left corner and the bottom point as the bottom right corner. Again, I just want to use my x and y position for this, so I'm going to go x minus 100, and then y minus 75, x plus 100, and y plus 75. And then that is just going to create a big rectangle. And I'm going to be using draw rectangle so we can actually see where exactly it is. The object we're going to be doing is going to be a wall, as it always has been. Precise is going to be false, and not me is going to be false. And then I'm going to say found equals true, else found equals false. And then here I'm just going to go draw rectangle, x minus 100, y minus 75, x plus 100, y plus 75, and I do want it to just be an outline. So if I run this now, as you can see, I have a rectangle. And I found you. Let's actually make this a little bit bigger. Well, I'm going to make it a little bit bigger for the next function we're going to be doing. But again, this is going to work a lot like collision circle, where we can actually get the ID. So I'm actually just going to comment this line out. And I'm just going to go grab this, put it there. String found, turn this into a no one, and found equals. As you can see, I can also just get the reference, the instance ID. And that's how collision rectangle works. So the next one actually is not one I've ever used before. And that is collision ellipse. So collision ellipse, we're going to be designing it the same way that we design a rectangle, but it's going to have a pretty key difference. So I'm going to go back to my paint application here, and I'm going to draw a rectangle. So what ellipse does is it's going to take this rectangle, and it is going to use it to draw an ellipse inside of it like that. So I'm going to feed it the coordinates for this corner and the coordinates for this corner, and it is going to create a elliptical shape inside of it that is going to be our collision area. So we'll only be colliding with this region in here. Actually, I can just use a paintbrush or a bucket. So the yellow area is where our collision is actually going to take place, but the coordinates that we're going to feed it are going to be the rectangle. So I'm going to make this one a bit bigger. I'm going to go x minus 150, y minus 125, x plus 150, y plus 125. The object is going to be a wall. Precise is going to be false, and not me is going to be false. change this back into a Boolean. Comment that out and draw that. And then I'm actually not sure, but cool, draw ellipse is a function. So x minus 150, y minus 125, x plus 150, y plus 125, outline is true. So let's see this work. Let's actually make it a little bit more elliptical. Let's go y minus 100. There we go, that's nice and elliptical. So as you can see, right here, that wall would be inside of the rectangle that I have defined, but it's not inside of the ellipse, whereas if I move over, it enters the ellipse. This is honestly just the same thing as collision circle. The only difference is it's kind of like collision oval. This one to work the exact same way in the sense that you can either get a true or false value or the ID of the instance. So the next one we're going to be looking at is going to be collision line. And collision line is going to work the exact same way. The only difference is that it's going to be a line. So I'm going to go x, y. You got to feed it 4 coordinates, the beginning of the line and the end of the line. And I'm going to go x plus 150, y, sorry, 250, I guess. No, let's just do 200. The object I'm going to look for is O wall. Precise is going to be false. Not me is going to be false. So yeah, the first coordinate you're going to feed it is going to be the origin of the line, and then the second coordinate you're going to feed it is where the line is going to. The line can go in any direction. It can even be angled. In this case right here, I'm just drawing it straight to the right. And again, this can be used to return either true or false or the instance ID. So I'm going to say if collision line found equals true, else found equals false. And then here I'm just going to draw a line. As you can see, I have a line there that is going from the very center of my sprite at my X and Y position, and it is extending out 200 pixels. And then if I touch something with that line, found you. And when I said that I use collision line like in combination with other collision functions to do line of sight, what I'll do is like I'll see whether or not an enemy has me within a circle of them, and then if I do, have, if the player is within like a certain circle of an enemy, I will then use collision line from the enemy's position to the player's position, and I will see whether or not a wall exists along that line. So I'm going to see whether or not I'm within, the eye range, and then once I figure out whether I'm within the eye range, I am then going to figure out whether or not there is something obstructing the line of sight. And if you're really curious about how I do that, I actually made a video on enemy line of sight, and I'll put a link to that in the description down below. Like I said, collision line can be used to either get the ID instance, or it can be used as a true or false. It's pretty versatile that way. All of these are actually pretty versatile that way. Again, every single one of these functions also has a list variant on it. So the next one is actually going to be collision point. So collision point is going to be checking for a collision with a specific instance at any given point, any specific X position, at any specific Y position. And then it is going to be either returning a true or false, or it's going to be returning the object ID. Well, it just returns the instance ID, but it can be used as a true or false. And for the sake of showing you how this works, I'm just going to say, if collision point found equals true, else found equals false. And there's honestly not a whole lot to show about this, because like I said, it is just looking at a very specific point. The point that I'm going to look at is mouse X and mouse Y, so that I can just hover the mouse over things. I'm going to check for instances of wall. Precise is going to be false. Not me is going to be false. That super doesn't matter in this point, because I'm not actually going to be colliding with it with the player. I'm just going to be using the mouse. So with this, every single time that my mouse position enters an wall, the found will be marked as true, and the player will have found me written over his head. Again, like I said, it is just taking any arbitrary point that you feed it, any combination of X and Y that exists within the game world, and it is going to be seeing whether or not one of those is there. This also has a list variation to it, where you can see how many and affect a series of things. But with that, I'm just going to run this, and you're going to see, I'm still drawing my line. If I hover over the wall, see, found you. But yeah, I feel like this video wasn't quite as intensive as my last one on basic collisions. But one thing that's actually really cool about these advanced collisions is that they don't require any kind of collision mask. You are checking areas and regions. I am creating a region in which to be collidable, and then I am seeing whether or not a collision is happening within that created region that I make at any given point. And that's what I think is actually really cool about these functions, and what actually makes them so handy. I use collision circle specifically quite a bit. I think the main reason why I'm going to use collision circle more than the rest of these is that as much as we are creating a digital space, when it comes to interactions, like nothing in the real world is hard and rigid. Well, nothing natural, at least. So like when I'm doing things like, line of sight or really anything, I'm going to try to go with more of a rounder shape, because it feels more natural. And when things feel more natural, and if things behave the way that the player expects them to behave, then it's going to increase immersion. And that's something that we really want to do when we're making games. We want to make them immersive. We want our players to get lost in whatever it is that we put in front of them. And in my opinion, the most important thing when it comes to immersion is how things feel. Do they feel artificial? They can look artificial left, right, and center. That's absolutely fine. But if it feels artificial, that's when it gets a little bit immersion breaking. So by having things, generally speaking, work on a bit of a more rounded sense, then it creates the natural feeling to the interactions within your game world. But that's all that I have for you guys today. I just wanted to go over these collisions. There are a couple more collision functions that I still need to go over, and they include things like point and triangle. But yeah, I'm going to put a link to my basic collisions video in the description down below. I'm also going to be editing that video and putting a link to this one in it. I'm also going to be including a link to my enemy line of sight tutorial in the description down below. If you have any questions about what I have done here, or you have any feedback, you can absolutely feel free to go ahead and reach out to me either through comments or comments. If you have any tutorial requests, please comment those. For the first time since I started this channel, I actually have a rather long list of backlogged tutorial requests. So for the next quite a while, I'm not going to be making tutorials that I choose. I'm going to be making tutorials that you guys choose, and this video is one of those examples. So if you have a tutorial you want to see, you can go ahead and comment it, and it will get added to my list of requested tutorials that I am currently making. Other than that, I'm just going to say thank you very much for watching. Please like, comment, and subscribe. I hope you guys are having a good one. Peace out.